Hi, my name is Alex Soul, and I'm a sales engineer here at CoreOS. Recently, I've had a discussion with a large enterprise team who wanted to be able to scale out their continuous integration environment. I wanted to showcase how Kubernetes can provide a potential solution to continuous integration, scalability, and elasticity. Let's take a quick look into our demo architecture. Demo environment consists of tectonic cluster with Jenkins master and workers running inside containers on top of Kubernetes cluster, along with a helper process named Jenkins scaler. Running Jenkins inside containers can have benefits and availabilities such that Kubernetes can react to failures within the system. If a Jenkins worker dies, or a node running the worker has a failure, or the node simply disappears, Kubernetes can quickly react to this failure and bring up a new Jenkins worker node. Apart from the benefits and availability, Kubernetes can also help out with scaling up the Jenkins cluster. For demonstration purposes, I've created a container called Jenkins Scaler. Jenkins Scaler reaches out to a Jenkins API to get information regarding the status of the jobs. This information includes things such as the number of tasks running, where they're running at, which nodes are busy, which nodes are idle, and things such as the number of tasks that are in the queue. Based on this information, Jenkins Scaler can now implement and make decisions based on the Jenkins view of the world, which means that based on the primitives that we have in Kubernetes, Jenkins Scaler can simply ask Kubernetes to scale up the worker cluster, such as increasing the number of workers. One interesting aspect with that is that Jenkins Scaler can also make decisions to scale down the cluster as tasks in the pipeline complete and we have no longer a need of running a large fleet of Jenkins workers. With that said, let's take a quick look into our demo environment. As you can see, we have the Jenkins dashboard here, and within our dashboard, we have two workers available to Jenkins called Jenkins builders with suffixes. And under the hood, we can actually see that these are really containers that are running in our tectonic cluster. These containers are managed by higher level objects called replication controllers. Based on replication controllers definition, Kubernetes essentially schedules the pods across our nodes. Within our cluster, we do have four different nodes that are powering up this infrastructure. Going back to our dashboard, there's a process called Neverending Job, which is an infinite loop designed for the demo purposes to be able to schedule tasks that never complete. So we'll spin up a couple of these tasks to start our pipeline process. As you can see now, both of our builders are currently executing tasks, and we have no builders left to be able to execute the next job. So we can start building up our queue. And what's going to happen under the hood is that Jenkins Scaler will understand that all our workers are busy and we have no idle workers to be able to execute the next job, and we have tasks that are available in the queue. And based on this information, Jenkins Scaler will quickly go ahead and talk to Kubernetes to spin up more workers. And essentially, this is done under the hood by simply increasing the number of pods that are required in our with our replication controller. And as these workers join the cluster, they will let the Jenkins master know that there's now a new builder available to be able to schedule tasks in. So let's build up a couple more of these jobs to start simulating some high workload usage on top of our cluster on top of our cloud environment. As you can see, we now have about 7 workers that have horizontally scaled up, and they're all getting more tasks as we schedule them, and we're able to parallelly process all of them as they come. Because we're running in a cloud platform, we can also make use of some of the auto-scaling group functionality or scaling group functionality that the cloud providers typically offer. This means that while we're running on only 4 nodes today, we can basically scale up our Kubernetes workers, therefore also scale out the Kubernetes cluster alongside with Jenkins infrastructure itself. With that said, once the tasks are completed, this will be simulated by manually killing the processes. We can also shrink down our cluster as well. As you can see, now we have about six workers and only about 3 jobs, 2 jobs that are currently scheduled. So that means we have 4 idle nodes. Based on the parameters that are passed to the Jenkins scaler knows that we only need 1 extra idle worker. So based on that, it'll basically shrink down the actual number of Jenkins builders. It also does this gracefully, meaning that it understands the tasks number 45 and 49 were scheduled on these last 2 builders and decides not to kill them and keep the task running, meanwhile only killing the node workers that are idle, allowing us to horizontally scale out and scale back in. I hope you enjoyed this recording. Thank you for your time.